Today we're going to be talking about recursive rules and sequences. Okay. In the past, when we've been dealing with explicit rules, we haven't really put those terms on them. But what you've been dealing with in the past is an explicit rule, versus today's rule, which is recursive. Explicit really relates it to the term number you're on. Whereas recursive, you're trying to relate your next term to a previous term or a previous set of terms. Okay? Explicit, you're writing a rule based upon the term number, based upon n. So if you think of your table, n and a sub n. Okay? Explicit, you're writing your rule based upon this. Recursive, you're trying to write your rule based upon that.
Okay, that makes a lot more sense.
Okay.
The math with McCoy thing, they have those quick quizzes and like the questions, and a lot of them ask for explicit answers or explicit rules and recursive rules, and I was really confused. And I was like, oh, do I need to know that?
Yeah. So if you use the website and you go to any of the quick quizzes, remember those. I mean, they're pretty good, but sometimes they'll be a little off because it's from another textbook. So most of the time we're pretty close, and there's some things you can do. If there's stuff you just haven't learned about yet, then you just have to ignore that part. But yeah, we're going to go recursive. Today is what we're going to be talking about. So if you look at your core concepts here, this is page 238, by the way, if you didn't find it. Recursive equations for your arithmetic. Remember, this is when you're adding. Okay, in geometric, where you're multiplying. Arithmetic here, a sub n is equal to a sub n minus 1 plus d. It means you take the previous term and you add something to it. Okay? Whereas geometric, a sub n is equal to r times a sub n minus 1, meaning you take the previous term and multiply it. So like, for instance, if I'm saying n is, if I have n and a sub n, whereas this would be okay. In this rule, we're multiplying by 2 every time. Okay, so I'm taking a sub n is equal to a sub n minus 1 times r. So my rule here would be a sub 1 equals 2. Okay, that's my first term. You always say where you're starting. My first term is a sub 1. It's equal to 2, and then my rule is the next term, or a sub n, is going to be equal to 2 times a sub n minus 1. Okay, and that 2 being this 2, not that one. I should have probably used a different pattern, but that's okay. So to find this term, I multiply 2 by that. To find that term, I multiply 2 by 4. To find that one, and so on. So I'm relating. To find the next term, I'm relating the previous term, or some set of previous terms. Remember, that is versus what we've done with explicit. Explicit said, so this is recursive, explicit said, if I want to know what a sub n is, I take a sub 1, and I multiply it by r to the n minus 1 power. That's the pattern you've been with. This is stating, I need to know first a sub 1, I need to know r, and if I want to find another term, I need to know what term I'm going to be dealing with. So I'd be looking at this. So like if I wanted to know the 5th term, hopefully I'd use this rule, but if you didn't, you could put in 5 here, and 5 minus 1 is 4, and 2 to the 4th times 2 would give you 2 to the 5th. Okay. 2 to the 5th times 2. Okay. You're using your explicit rule in that case. You're relating this up here to that. Okay. Everyone understand the difference between the two? Okay. So if I'm going through and solving some of these, let's go ahead and take a look at the next page. Okay. If I'm going to go ahead and use those rules, first thing I have to be able to do is read the terms and read what the rules say. So they're saying a sub 1 is 2, meaning I start with 2. And I am going to apply this rule every time to it. So tell your neighbor what that says. Okay, so as I heard a bunch of you say, you are adding 5. So the next term is equal to the previous term plus 5. That's what, if you want to kind of put words to it, the next term is equal to the previous term plus 5. It's previous term plus 5. So 2 plus 5, 7. 7 plus 5. Okay? So it's not meant to be difficult right now. It's just meant to get you used to reading what's going on. 846. I don't think that's what's going on. Okay? So this would be a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Or if you think of it in terms of n is 1, n is 2, n is 3, n is 4, n is 5. Okay? All right. Go ahead and talk to your groupie about that one. What's happened on number 2?
F is just stating that.
Okay, time's up.
F is like what?
Now, hey, this one's a bit more complex. This says f of 0. F of 0 is equal to 1. Now remember, this is function notation. F of 0 is 1. That's a value of a function. So f of n is equal to 2 times the function of n minus 1, or f of n minus 1. Okay? So if I were to say plug in 0, because I know what f of 0 is. What is f of 0 again? 1. If I was to take f of 0 and plug it into this function, meaning f of n now is I'm going to write this out the long way here. Okay, f of n is now, I'm going to put in 0. That means this is 2 times, tell your neighbor. Okay, how many are with me so far? Okay, f of 0 is equal to 2 times f of what? Well, what's the problem right now? You have to double f of negative 1. What is that? Well, it has nothing to do with that. Do we know what f of negative 1 is? No, what do we know? Yeah, we know what f of 0 is. So if this was f of 0, we could actually put something in for it, but we can't put anything for f of negative 1. Okay, how can you get f of 0 here? Talk with your neighbor about it. Hey, time's up. Any thoughts? Raise your hand, please. No one brave. Yeah?
Me and Mackenzie talked about assuming that 2 is the rate and then dividing by 2 to go back from 0 to negative 1.
Okay. All right. Let's see if that works here in a minute. Any other thoughts? Yeah? Set what equal to 1? Okay, all the chit-chatting. Okay. I think you're right in your thought process. So when you're saying set it equal to 1, do you mean make, rather than this f of 0, make this f of 1? Can't just do that. No. I mean, you're just saying completely get rid of all this and just say equals 1.
The other side.
Oh. Okay. All right. So now you have that. Okay. How does that help us? Okay, you could say f of negative 1. You know what that is now. What is it? 1/2. Okay. How does that, we want to find the first 6 terms, so we're kind of going the wrong way. But possibly, I mean, that's kind of coming, I think, what you were saying, right? You could then figure out what your rate is, right? This is geometric. Okay, you could figure out your rate. What is it? What are you multiplying by every time? Yeah, let's show what we have. We have f of 0 is 1. We have f of negative 1 now is 1/2. So what would f of 1 be? What's f of 2? Everyone see what's going on there? So we're doubling every time. Okay, that definitely would work. Any other ideas? Yeah.
Okay, so I did that completely different. So I just kind of thought of it of not of regular geometric series, and I just saw that it was that the rate was 2, and then I took 1 and then I just multiplied it by 2, and then I took the answer and then I multiplied that by 2.
Okay, so you said that I know my rate is going to be 2, so you just did 1 times 2. Okay. So kind of the route you're going on that, without maybe thinking you're going that way, is you really are trying to make this thing right here equal 0. How can I make this equal 0? Because I know f of 0. So it would be nice to have 2 times f of 0. How do I make that 0? Yeah. Yeah, if you make n equal 1, so rather than having f of n, now you have f of 1. And this is no longer 0, it's 1 minus 1, which is f of 0. And f of 0 is 1. So you would then have 2 times 1, which is 2. This is f of 1 still. Okay, so f of 1 equals 2. That's probably the route I would have went on it. This route definitely worked, though. It's always interesting to me to find out where you guys go with that. Okay, and so Kendall, you're on the right process. You just didn't think to yourself that step. Okay? All right. Anyway, we could then go here to figure out we're multiplying by 2. You could actually plug in and you could keep going through the process. Okay, that's the whole piece worked out if you want to see it. But that's a lot of work showing. Okay? I wouldn't expect to see all those pieces. But all right. Good discussion. I want you guys to take a look at number 3 and actually number 3. Let's just start with number 3. Okay? Okay, can I have your attention back up here? Guys, off to the side here, I'm going to give you some guidelines. Okay, they're not hard and fast things that you that are going to work every time. Sometimes you're going to get to these by different steps or different ways, but I am going to give you some steps that I would look for to begin with. Not always easy, these patterns, okay? But the first thing I do is I look for the basic recursive rules. So if you think back to our previous page where we had those two, if it has a common difference or a common ratio. So the first thing I do is I look for a common difference. Okay? So I ask myself, is there a common difference? In other words, am I adding something every time? And in this case, I am. I'm adding 3 every time. What does that mean? It means it's a very easy pattern. We start with a sub 1. We always say what we start with. That's 9. And my rule is a sub n is equal to, I use this formula. I mean, we've already defined it. If you have a common difference, you take a sub n minus 1, and you add that difference every time. That is your rule. Remember, this is saying the next term is equal to the previous term plus 3. Okay? Starting with 9. So that's the one we start with. So that's why we have to put our starting point. Otherwise, you would go, well, hold on. What did I add 3 to get this? Well, technically, you could, I guess if you work backward, you could, but we have to have a starting point. Okay? What do you guys think I do second? Yeah, look for a common ratio. Is there a common ratio? Well, obviously there wasn't in that one, but if you look at number 4, is there a common difference? Hopefully really quick you go, well, that's 30 and that's like 12. So no. Okay, is there a common ratio? Remember, if you divide that or that by that, what's 20 divided by 50? 2/5. What's 8 divided by 20? 2/5. This one's a little tougher, but that divided by that will give you 2/5. If you're doing it on your calculator, 2/5 is 0.4. So each time you are multiplying by 2/5, that's a common ratio. A common ratio helps us out because we then use our geometric sequence formula. So everyone write down what your rule would be. Number 4. Okay, a sub 1, 50. A sub n is equal to r, 2/5, times n minus 1, or a sub n minus 1. Okay? R times 2/5, or 2/5 times a sub n minus 1. R is 2/5 then. Okay, questions? Those are pretty easy. All right, let's take a look at number 5. Give it a go. Okay, common difference, yes or no?
No.
Common ratio, yes or no? No, therefore we move on to the next thing. I would try to add or subtract. Now remember what we did in the past, we were relating n to a sub n. Here I'm relating a sub n to a sub n, or n minus 1, or n minus 2, or any of those. So I'm going to try to add or subtract prior terms. Actually, let me add here. Add or subtract or multiply and divide. I guess I'm being redundant when I'm saying add and subtract and multiply and divide, especially now that you guys use positive, negatives, and fractions, but that's okay. Okay, prior terms to get the next. So what that means, it would mean like, hey, can I add 3 to 4 to get 1? No. I could. Okay, I could subtract 4 from 3 and get 1. Could I subtract 1 from 4 and get negative 3? Can I go negative 3 minus 1 and get negative 4? Okay, so really what I'm doing, now we've got to figure out how this works. To get a sub n, we need to know where we're starting. So a sub 1 is 3. And a sub n, so since we're subtracting previous terms, like 2 of the previous, that means we probably cannot start till right here. This is a sub n now. Okay? So if we think of this term right here, our third term as our a sub n is equal to that term. So what is that in terms of a sub? A sub n minus 1, it's the term prior, minus a sub n minus 2. So this one would be called a sub n minus 1, and this one is a sub n minus 2. Is it challenging? Yeah, kind of challenging. If I'm writing my Like, if I want an example for each of these, well, this is number 1, hashtag 1. This is, or sorry, it's hashtag 3.
Stop it.
I'm assuming if you put hashtag 4 in on Twitter, you're not going to get any of those problems. But hashtag 4. Okay, here is hashtag 5. Dallas. There's D. All right. I flew to your city, Dallas, on the way to my trip. Flew into Dallas. I went up and tried to get free stuff. So I know Dallas. Hook me up, and they didn't care. They're like, whatever.
Yeah, Dallas, come at me.
All right. Good? Easy? Not so much. Okay, but it's giving you rules to go by. So I want you to try number 6 now. Giving you some test rules there. Okay, time's up. I have your attention back up here. Okay, looking for a common difference. Is there one? Common ratio. Can you combine a prior term? Usually if I'm doing that, I'm starting right, usually around the 3rd, but can I combine any prior terms to get the next? Okay.
Okay, well, 1 plus 1 is not 1. Wow. Thank you. Great. Mathematician, right? Right. Oh, gross. Like, so combine 1 with 2? Or 1 with 1? That's
Okay, now this is where we're combining previous terms. So it's still recursive because we're using previous terms. But we're going to use previous terms along with in, the position of the term. Okay, and I'll tell you that is what this pattern is here. You're somehow combining a previous term with a position to get a sub n. So I will help you out with the beginning. A sub 1 is equal to 1. A sub n is equal to, that's where you guys go. Use the pattern of combining previous terms with the term position. Figure out how you can relate a previous with that to get the next. Work together. Before we talk about it, I'm going to tell you the best place to focus for this problem are those two right there. If you can focus on those two, it'll help you out. All right, here we go. Well, Sylvia, what'd you get?
A sub n equals a sub n minus 2 over n.
All right. A sub n minus 2 over n. So notice this right here is taking that and dividing it by that. Okay, it's taking 1 and dividing it by 3. Okay, or actually it's taking, that 1 and dividing by 3. Okay, this, the 1/4 is taking that 1 and dividing it by 4. The 1/3, or 1/15 is taking that 1/3 and dividing by 5. Okay, so you're taking the two terms, or the a sub n minus 2, so you're going 2 prior and dividing it by your current term number. Now, by the way, just so you know, if you wanted to divide this by this to get that, you could say n minus 2 down here. That would be saying taking that and dividing it by that. That's not what we're doing here, but some of you are asking that. They are not easy always. Okay? There are some guidelines. That goes with number 6 there. All right. Hopefully that helps you out a bit. I think that can be a very confusing piece there. I want you to take a look at the next page. Number 7 and number 8. Write a recursive rule for the sequence. Remember your 2 recursive rules. I want you to write them up here. Write the one for addition and then the one for multiplication. So your arithmetic and geometric right here. Okay? Go ahead and write those two rules out. Okay. So in order to write these rules, we need to know a couple things. We actually need to know a sub 1 also. So always make sure you list your a sub 1. Okay, so you have your two different guidelines there. Bless you. Okay? So tell your neighbor what your difference is in here. Tell your neighbor what a sub 1 is. Okay, the easy part. This is linear, meaning it is arithmetic. And the slope is always our difference. What is a sub 1? How do you figure that out? Plug in. Yeah, you plug in 1. To find a sub 1, you plug in 1 for n. Okay? Now write your equation. Write your rule out. All right, there we got it. All right, is this one geometric or arithmetic? Geometric. Tell your neighbor how you know.
There's multiplication.
Okay, time's up. Hey, just like arithmetic is in linear, geometric is in exponential form. You're multiplying here. You're adding or subtracting here. Arithmetic, geometric. What is r? -2. Okay. A sub 1, we've got to plug in that 1 for n. Hopefully you'd recognize that as 10. Okay, questions? All right, last two. Number 11 and 12. You're going the other way now. You're going from an explicit to, or from a recursive to an explicit. So first thing, write your rules. Different rules. These are the ones you've been using in previous days, right? Should have one for geometric and one for arithmetic. Okay, those are our two rules. Geometric and arithmetic there. So in order to write them, you need to know if you're doing an arithmetic sequence, you need to know D. And I know I'm doing arithmetic because of the addition. Here I'm doing multiplication, so that's geometric. I need to know D and a sub 1. If I'm doing geometric, I need to know R and a sub 1. Okay? So, do we know either D or a sub 1? Which one do we know? We know a sub 1. It tells us it there. Do we know d? What is it? 7. Yeah. So we plug it in. Simplify. A sub n is equal to negative 8 plus 7n. If you flip them, I'm fine with that. Okay. If you put 7n minus 8, that's okay. All right. What is r here? Also known as 1/5 or 0.2. I'm going to leave it in decimal because they started it there. Yeah. All right. I have officially, we finished. Okay.